So we are moving. So the class has started in NX. So according to the question, we have 10 questions there. Let's see how far we can go. The first one was on, let me see the question again. According to the first question, the question number one.
Officer, please, which question are we using?
There's a question here. They say it's an assignment, Abi.
Oh, okay, okay.
2020, we'll solve a past question tomorrow. I learned that we need to explain this to you people to also help you solve and also help you to understand one or two things that relates to the exam. We know they are not going to set theory, but it's an assignment. FBA 840 2023 assignment. Are you there? Are we all with it?
Yes, sir.
So according to the question, it said number one, the vetting officer attached to an advertising company wants to examine the brand of cars display and the preference car type of young graduate. He then collated data on 300 newly employed graduates as follows. There is a Nissan, there is Toyota, there is BMW, but car types and the professions, accountants, they love Nissan, they love Toyota, they love BM, administrator, they love all this. But according to the question A, is that we should construct a simple bar chart of the type of cars. That is the first question. Before we talk about component bar charts. First, we all know by now, in case you don't know, bar charts always has space in between. Each of the space must be equal. That is a rule you need to understand. To construct a bar chart, the space between each bar must be equal. And the breadth, either the breadth or the width of each bar must be the same. The height could be different, but the breadth or the width must be the same. If I'm measuring 1 centimeter for the breadth of the bar, it will be the same thing across board. So there are different types of bar charts. We have simple bar charts, we have compound bar charts, we have component bar charts. There are 3 types of bar chart at least we can remember. 1 is simple bar chart. 2 is component bar charts. Maybe the 3rd one is compound bar charts. According to this question, the simple bar chart is for us to illustrate types of cars as far as this particular question is what concerned. So all I'm going to do, first of all, I'm dealing with cars now, which is a simple. Nissan. What's the total number of Nissan? 20 plus 55 plus 30. That is 105. Agreed? Hello?
We can't see the screen. Oh, I can't see the screen, sir.
No.
We can't see the screen.
But do you have the question?
Okay, you mean the question. Okay, let me go through the question, sir.
You have the question. When I want to solve, I go to the screen. I'm just trying to analyze things. We all have the questions. I hope that is clear. Please, everybody should look at this question. When I go to the board to draw, you will see the screen. For now, me too, I'm holding the question to call 1 or 2 things. Question 1, that's where we are. Cars, we have Nissan, we have Toyota, we have BM, and there are professions of those that like one type of car and the other. Accountant, they like 20 Nissan, 38 Toyota, 60 administrator, then economist. But according to the question, say we should construct simple bar chart of the type of cars. So this bar chart I want to construct now is just cars. Are we all with the question now?
Yes, sir.
Hello? We're all having the question, Abi? Hello?
I presume
Now,
so, sir.
Before I go to the board, Nissan, total number of car for Nissan, 20 plus 55 plus 30. That should be 105. Agreed? Toyota
Yes,
total
sir.
number, 38 plus 40 plus 12. That should be 90, I suppose. 38 plus 12 should be 50. 50 plus 40 should be 90. Toyota total number is 90. BMW is 125. Is that clear?
Yes, sir.
So I just called that one so that you can remind me. Question A now, I want to solve. That A has Roman figure 1 and 2. My putting Roman figure 1 is to construct a simple bar chart. Simple bar chart. Is it? If you draw your bar chart very well like this, we'll draw a straight line like this. Don't mind this line is straight. This one is also straight. So here will be the types of car. This place will be types of car or cars. And this side will be the frequency, number of cars. So, and you know that this is a kind of a graph or your notes. You have drawn the line like this. Nissan is 105. Toyota is 90. BMW is 125. So you are going to do a kind of a scale because we can't be writing 105, 90. No, we can't do that. All we need to do is the origin. We can give a scale. You know, if you are using graph, it could be 2 centimeters to 1 unit or 1 centimeter to 2 units or 5 units. Because the thing is giving us 100 and something, we can decide to say, here is, let's say, 50, 100, 150, like that. Is it okay? On the vertical, which is the number of cars, to be 105. We have seen Toyota to be, we have seen a BMW to be 125. And the question, which is question A, which has 2 parts there, they say we should draw first of all a simple bar chart. That simple bar chart is just a bar chart for cars. First, from here to here, we'll give a space, we'll draw a line. What is it called? Nissan is 105. So that is 100 you are seeing there, probably 105. The line could just be here. We'll draw something like this and call it what? Nissan. We'll write it in full. Nissan. That Nissan, that is how tall it is. The space here, let's assume is 1 centimeter. Another space again will also be 1 centimeter. Maybe the space in between here could be 0.5 centimeter, something like that. So the bar, the breadth of the bar must be is a unit that must be the same thing with other bars. The space in between each bar must also be the same. That is the condition for drawing a bar chart, whether simple bar chart or compound bar chart or component bar chart. So I draw another one. You are aware that, what is it called? Toyota, which is TY. Toyota is 90. On my hand, he has gone far. Here is Toyota. See where I'm drawing. This other line is not important. So this is where I am now, maybe 90. You can see the space, 90. That is for Toyota. Another space again, the other one is 125. So I can go a little bit higher, and we'll have something like, remember, this is a BMW. What you have seen on the board is question A, Roman figure 1, simple bar chart on types of what? Cars. The cars will be the horizontal line. Nissan, the first one, is measuring 105. After 100, a little. Toyota is giving us 90, which is below 100, which is 90. BMW is 125, which is higher than Nissan. So that is how to construct a simple bar chart. Is it clear? Any questions? Are we following? Choma? Are we following? Can I clean the board? Give me that power bank, the mommy power bank. Are we there? Oh.
Few seconds, sir. We're with you.
I just want to know whether
No,
you are getting it. That's simple.
Let's quickly draw.
Yes,
Please
with
do.
you, sir. We are following, sir.
Remember the rule. Difference between the bar must be the same. The breadth of each bar must be the same. The height can be anything based on the frequency you were given. The old one. The old one.
Hello,
now
sir.
bring it there.
Hello, sir.
Yes.
Hello, sir. Sir, the question.
I can hear you.
Can you hear me,
Hello,
sir?
I can hear. Yes.
I want to ask questions.
I can hear you.
The question said, okay, construct a simple bar chart of the two of the type of cars and impose the component bar chart on it. So I heard you saying that you want to clean it, so I became confused.
No. There are simple bar charts we are going to. And that was why if you check the second question, it was asking you the advantage between simple and components. There are two graphs you are going to plot here. We'll do the simple parts, which is this.
Okay.
The second part will be the component, that where we're going to separate each of these lengths. We are going to divide them into three, showing three types of pepper.
All right.
That is a minute, yes.
Yeah.
Because if we impose it on this, that simple bar chart, well, nobody will see it. So we have to draw another one. Yes. We have to draw another one, which is also simple bar chart, but in this area to be component. We'll now be doing the part on it and separate the rows. Sit now. Is it your mom there? Honey. Where's the power bank?
Bagana, you can mute yourself. Bagana, you can mute yourself.
Okay.
Already? Can we do the components?
Yes, sir. Go on, sir.
Good. So it is this same simple bar chart I'm going to draw, but it's just that I will try and redraw it so that this simple will still be retained. This is what I'm going to do now. Probably do it very nicely. This is still the cast. This is the origin as we did it before. 50, 100, and then 150. Here is a Nizan as we did before. That was 10 like this. Toyota was 90 somewhere here. Don't mind the drawing, but at least you have seen, you know what we are talking about now. BMW, this 125. Good. Now, this is our simple bar chart that we had before, but now we want to make it component bar chart by just doing a kind of, partitioning, which makes it component. You will agree with me that in that question you copied, or that is with you, there is 3 components there: accountant, economy. I mean, which one again? Accountant what again? I'm not with the question now. Accountant.
Accountant, administrator, economist.
Good. Now let's focus on Nizan. For that Nizan, accountant value is 20. Have it?
Yes, sir.
Then administrator is a particular value. The last one is also
55.
We'll now turn the thing into percentage. And when we turn into percent, we'll be able to share this particular bar into three components, and probably represent them with different type of shading, so that we can illustrate that this type of shading is for accountant, this one is for administrator, this one is for the other part. So this is 105. This 105 will be divided into what? 3. And dividing into 3 is a kind of percentage we are going to look at. But the first is 20. The highest there is, but let's take it one by one. Accountant first. Then we'll move to the next one and the other one. So we divide it into that kind of ratio. We know that the smallest there is 20. Oh,
That's correct.
the smallest is 20. So and the other one, I know say that 20 should be a kind of a little bit less than 20%. So we now, from 0 to 50, we'll take something like 20. I know it's somewhere here. I can now take my time, maybe represent it with this kind of, because this is board. That shading, this one I have done this way for accountant. And the other one is 30 what? Oh. What's the name?
Administrator is 55.
Economist is 30.
But which one follows? After accountant, what's the next one?
Administrator.
Administrator.
Which is
55.
how many?
55.
35. 35.
No, 55. 55.
So from this place, now, I have already constructed 20. From 20, I can measure 35 somehow. 35. The other one is what? 55.
55, not 35, sir. 55.
Okay, 55.
Administrator 55, yes, sir.
From this 20 now, I can just do the measurement, knowing fully well that the last one is 35, Abby.
30.
Yes, 30.
Okay, 30. So from here now, I can just measure something here. You know, it's a graph. From this 20, I stop. I now count. I got 50. So this 50 now, I may leave it blank, representing administrator. Why this one? To make things different, I can just put 0, 0, 0, 0, 0, 0, so that the thing will look a little bit different.
All right.
So this is the component. And when I finish, I will state something either up or down, stating that this either down or up, but whichever one. So I can now state clearly that this symbol, maybe let me just, this one I'm doing here, maybe like this. This way I'm doing this one. Line, that down one represent accountant. Then I'll draw another one, which is a plane. It will represent administrator. Then the last one to show, you know, what is they call it? A symbol of what I've just drawn, what he represents. I'll draw another one like this, which, you know, I put 0, 0, 0, 0, 0, 0, which is economics. And that's how I'm going to follow it. You have to show them what each of these your shaded components represent. And remember what I did? The whole thing was 105. I shared it into parts, which we call components, to show us accountants that love Nizam, administrators that also love Nizam, and economists that also love Nizam car. We do the same thing for Toyota. Toyota was 19 all, Abi. Accountant was how many? What was the total number for accountant? Are they there?
Yes, we are here, sir. Accountant is 38.
38. So I know it's somewhere along the line here. So I still do that same idea because this is the method I'm using for accountant. Then administrator, how many do they have?
40.
40. After 40, what's the next thing?
40.
12. After 40, 12. 12.
And I look at it 40 and I measure it. From that at 8, I stop, I measure 40. I know that this one is small, but your ruler can do a very good job. And if it's a graph, actually, it can easily show you everything. So that is it. And the last one was BMW. And the total was 125. I know 38, Abi. Is the accountant 38?
No, it's 60 for BMW.
Okay, Okay, for BMA, accountant 60, Abi.
Yes, sir.
So I move like this. Then admin, what is it?
25.
25. Then another one is 12, Abi.
No, the other one is 40.
No, what is it called? Admin, you say it's 40.
No. Accountant is 60.
Good.
Admin is
Then
25.
admin.
25.
Okay, then economy is what?
40.
40. Okay, let's economy is 9 days smaller pass, Abi.
No, admin is smaller. Admin
Okay,
25.
admin is then the other one is 40, Abi.
Yes, sir.
Okay. So let's believe you have measured it like that. So you have just with this is what we call component bar chart.
Charts.
Component bar chart. Those ones that normally have straight line attached to them, where you have maybe this Nissan now, we have a straight line up to 3. That is the one we call compound. Instead of us dividing it into one big bar, we'll do every straight line for each. One straight line for accountant, another straight line. All of them with just this particular bar, we'll just split it into vertical, up to 3, showing where each of them get to. The one of 30 will be also as lengthy as that 30. Another one will be longer, another one will be smaller, but all of them is still in one bar chart of Nissan. That one is called compound bar chart. But why this one is component? When you split one big bar into small, it's called component bar chart. So that's the answer to that question. Question A. Question B is grammar B, which the question is letting us find out the advantage of something. But this is the main thing, which I believe is calculation. The grammar is not a serious issue. Anybody can construct that, but we'll try and still give you some. Are we through with the board? Are we still there?
Yes, we are done.
Yeah, we are done, sir.
Okay. Still on question 1, but the last part there, which is B, let's just give you small grammar on that. So according to that question B, the question is trying to see the advantage of component bar chart over simple bar chart. The advantages are as follows. The advantages are as follows. 1, it shows proportions. It shows proportion or relative numbers. It shows proportions or relative numbers for various categories. It shows proportion or relative numbers for various categories. And you are aware that simple bar chart does not do that. It just draws it straight. It doesn't. Number 2, it allows for visual verification. It allows for visual verification of the precision and logic of calculations. It allows for visual verification of the precision, precision and logic of calculations. Full stop. Number 3, it presents a visual summary. It presents a visual summary of a comprehensive data set. It presents a visual summary of a comprehensive data set. Full stop. I add one more, you can add more on your own. Number 4, it shows easy accessibility. It shows easy accessibility of different amounts or quantity of every component in the data. That's all for question number 1. We're moving on to question number 2. Question 2 has 2A, 2B.
Okay,
Roman,
sorry, sir.
yes.
I better repeat the last line, sir. The last one, sir.
Last one. I said it shows the different quantity of every component in the data. If I may add, without reference to the original data. Without without reference to the original data. That means I don't need to go to the original data to know the one for administrator, to know the amount for economists, to know the one
Sir,
for...
it shows reference for what, sir?
It shows reference of each component in the data without reference to the original data that was given as a question. What I'm simply saying that you can still put it, you can even develop more there. What I'm simply saying is that when the component bar chart is plotted, just seeing the component bar chart will let me know every quantity assigned in the original question for every component. I don't need to go to the question and say, accountant use this car, but with that component bar chart, I can easily know it without reference to the original data, which is the original question. That's what I'm trying to say there. And you can still develop more. Maybe make it up to 5. After all, the question did not say you must give a particular number. Abi, you can give as many as you like. So that's the end of question 1 on my own part. You can develop more. We are moving to question number 2. Are we set? Can we? Question number 2. Can we?
Yes, sir.
Okay.
Yes, sir.
Question 2. 2A says, what are the advantages of using a pie chart in data presentation? Let's give you a little advantages of pie charts. Advantages of pie charts. 1, it makes room. It makes room for easy comparison. For easy comparison between, it makes room for easy comparison between components of the variables. Number 2, it provides the summary. It provides a summary. It provides a summary of the data at a glance. It provides a summary of the data at a glance. Are you there? I said number 1, it make rooms, or it make room for easy comparison between components of the variables. That's number 1. Number 2, it provides the summary of the data at a glance. Summary of the data at a glance. Number 3, pie chart displays Relative proportions. Relative proportions of multiple classes of data. Pie chart displays relative proportions of multiple classes of data. Number 4, if they are with me. Number 4, size of the circle. Size of the circle can be made proportional. Size of the circle can be made proportional to the total quantity. To the total quantity it represents. Number 5, I believe. Number 5 as 5. It permits a visual check, a visual check of accuracy. Visual check of accuracy of calculations. Visual check of accuracy of calculations. That is the end of question 2A. Any questions?
No, sir.
Question 2B is a simple calculation we are going to do. The question says, the data below shows a collection of various types of raw materials used by advertiser to complete a batch of a project. There is pins. Don't forget, so that when I start solving, you remember for me. Pins is 15%, paper 45%, rope 10%, gum 5%, ink 25%. Roman figure 1 says draw a pie chart to illustrate the collection of raw materials needed for a batch of the project. For us to do any construction, we must change those percentage to degree, because pie chart is a circular representation of a data or graphical representation of data in circular form. And that circle represents 360 degrees. Get it clear? As far as you are asked to construct pie chart or whatsoever, if the data they give to you is in ordinary figure, it's a must. You convert it to degree. If it's in percentage, it's also a must that you must convert to what? Degree. And for you to do that, you need to assemble everything. According to the question, the first thing that was 15% is what?
Pin is 50%. Paper is 45%.
No, take it easy. Take it easy. You say pin, Abby?
Pin 15%.
Good. 15%.
Paper 45%.
Paper 45%.
Rope 10%.
Rope 10%. What else?
Gum 5%.
Gum Next.
Ink 25%.
Ink 25%. Is that all?
That is all.
Good. We add everything together. We know it's 100%. But we can still cross-check in case they made mistake in the addition. 15 plus 45 should be 60. And it's very clear that it's 40, then 100%. That should be the total. So we now start calculating 15 over 100, which is 15%, times 360. What do you have? Calculator can do that. 0.15 times 360. That's the meaning. This is for pin. 84, Abi?
Yes.
Eh?
54, yeah.
84 degree. Then we'll talk about paper. Paper is 45% times 360, which is degree.
162.
And there is 162 is degree. Then we'll have row. Row 10% times 360 degrees. We'll have something. That should be 36, Abi.
That's
I
correct.
think the first one is 54 degree now, not 84.
54,
It was
54.
54. I was
Yeah.
wondering. Good. So the other one is 162. Is that correct?
Yeah, it's correct.
Okay. So this one is 36 degree, which I believe is also correct. Gum. Gum is 5%. At least I did 10%. I got 36. 5% should be 18%. I'll be 18 degree. Agreed?
Yes, sir.
Good. Finally, ink on this corner will give me 25 over 100 times 360 degrees, which will give me 0.25 times 360. What do you have? Degree?
90.
90. So we have calculated the degree because we must get the degree. Because there are places in that question that they will ask us for degree and so on. We just fill in the gap. But first of all, like I said, as far as the pie chart is not in degree, you must convert whatsoever number they have used to degree. This one is so direct that your addition must be 100 because it's a percent. Sometimes it may be ordinary number. You need to add and get a different value, which may not be 100. So automatically, you will not be taking the question one by one, 15 over 100, and times 360, 45 over 100 times that. So take note of that and get the idea behind it. According to the question that I'm still seeing here, it said, draw a pie chart to illustrate the collection of raw material. And there's no way you can draw pie chart without getting the degrees, Abi. So I haven't found the degrees. Roman figure 1 is just for you to draw a circle. For you to draw, I know say this exam you are doing is not theory, it's because it's an assignment. But for you to draw a pie chart, you need a protractor. That protractor has degrees in it for you to begin to allocate or apportion the degrees based on what we just calculated. I need a pair of compasses to draw a circle for you to now start apportioning all the degrees. Is there any question on how to draw this? I was going to just draw a circle, but I've told you the idea. You need a pair of compasses, which you need to use to draw a big circle. Then the protractor, you put it inside that circle. That protractor has angles inside. Use it to allocate 84 degrees. You allocate 84 degrees in that circle. You allocate 54 degrees. 54 degrees, sorry. You allocate 54 degrees, you allocate 90. 90 is a right angle triangle, a right angle, which will give us a symbol of right angle there, symbol of a sector. So you draw and get your answer. And before I get to the drawing, Roman figure 2 say, how many degree of the pie chart represent rope, gum, pin? How many degree of the pie chart represent rope? How many degrees rope?
36 degrees.
36, yeah.
So you add degree of rope plus degree of gum plus degree of pin, and that is the answer to that question. Any question on that Roman figure 2? How many degree of the pie chart represent rope, gum, pin? The degree for rope plus the degree for gum plus degree for pin. I believe pin was 54 degrees, Abi. Gum, is gum 36?
No, gum is 18.
Gum is 18.
Rope is
Pin
what?
is 54.
Eh?
Gum is 18, pin is 54.
So
Rope
that
is
means I'm
36.
going. So it's going to be 54 for rope plus 18 for gum plus 54, Abi, for
No,
pin.
we have 36, 36, 18, 54.
54.
Good. So rope is 54, gum is 18, pin is 36. So you add the three together, and that becomes the answer to Roman figure 2. Roman figure 1 is to draw the circle and allocate which I'm going to draw on the board. But Roman figure 2, I hope that is taken. Rope is 54 degrees. Gum is 18 degrees. Pin is 36 degrees. So 54 plus 18 degrees plus 36, I believe a value must have been gotten by now. And that is the answer for Roman figure 2. Any questions? Roman figure 3 says if the total material is 12,000 units, how many units of ink are required? So that one, we must solve that one on the board to show you. So first of all, I start with the pie chart. Pie charts. So you use your protractor. This is Roman figure 1. We have just solved Roman figure 2, but we'll still explain. This is, you draw a circle like this, anyhow, and this is the center. You allocate things like this with your protractor. This should be 90, Abi. You put the value. You locate, I remember there was 18. You also take your time to locate this. Okay, maybe 18 here.
I think 18 and 162 should take a straight line. 18,
was there
162,
was there
yes.
162? Okay,
Yes.
there was 162, Abi.
Yes,
So
that would be 180.
162, that would be 180, Abi.
Exactly.
Let's let this one go like this. That's 180 on that corner, Abi.
Yes.
So then 18 and 162, maybe we'll do it like this. But all this thing I'm drawing will be with your protractor to allocate the degree. Oh. You don't just use your hand and begin to allocate the way you feel. But at least, because that 162 and 18 is 180, which is angle on a straight line. So you do that one. Then with that A180, you now use the protractor to allocate 18, which is for 18 is what? You say, what is the name?
That's gum.
So this is a gum. Then a 162, what's the name?
Paper.
Then the one of 90, what's the name?
Ink.
There are two left, and those two left are 45, Abi?
No, 54.
Anything else? Okay, 54 and 36. So
Yeah.
we can say that this one could be 36. What's that 36? What's the name?
Rope.
We can say rope. And pin, Abi?
Yes, pin 54.
So we can say we have allocated it using your protractor to illustrate that, or whichever method you have adopted. Then Roman figure 2, which we have, we saw 54 plus 18, if I'm not making mistake, plus 36. Is that correct? Roman figure 2, rope. Rope is, how much is rope? The degree for rope is what?
36 degrees.
Okay, rope is 36.
Yes, sir.
Gum is 18, Abi.
Yes, sir.
Then which one again?
Pin 54.
Okay, pin is 54. Okay. Okay, it's just, it's still the same thing. Okay. So 36 plus 18 plus 54. What is the result?
108.
Good.
108.
So that's the answer for that one. Roman figure 3, if you can still recollect, what is there? It says 12,000 units was for the whole raw material, Abi?
That's correct.
So that means 12,000 units is represented with 360 degrees. Let me remember the question again. The question says, what is it? The question says, Roman figure 3, if the total material is 12,000 units, how many units of ink are required? So in a simple language, the whole material is 12,000 units. Ink, what's the degree for ink?
90.
So you now write 90 degrees like this. I hope you see the way I put it. So you cross multiply. That means ink 360 times ink equal to 1,000, okay, 12,000 units times, okay, 12,000 units times 90. Ink will be equal to 12,000 units times 90 divide by 360 degrees. Then ink will now be 3,000 units. So ink will require 3,000 units. Is it clear? 90 in 360 should be 4. How many 4 in 12 should be 3?
That's correct.
And that is 3,000 units. Is it clear? Any questions? What's in again? Roman figure The last one there is Roman figure 4 for this question too. Is there how
Please, sir,
many
we're still
degrees?
writing. Hold on, sir.
Okay.
We're still writing, sir.
Shabi has seen the board, Abi?
Sir,
Right.
we're seeing the board.
No problem. Just right, I understand.
Hello, sir.
Are you ready?
Hello, sir.
I can hear you. Can we continue?
Yes, sir, I have a question, sir.
Oh, yeah, go ahead.
But,
Go ahead.
sir, like the 3,000 unit that we got,
Yes.
if we use percentage, we can also get the same thing.
The choice is yours now. It's okay. Because all you
Okay.
just need to do is, what is it called? Ink. Ink percentage is, say the degree is easier
25%.
for 25% of
12,000.
12,000. You get the same answer.
Yes.
It's okay. It's correct.
All right, sir.
It's just,
All right,
all of us will do the same thing. So it's even better.
Right.
Use another method like. Okay.
Thank you, sir.
The next one, which is number 4, you say what will be for, is it paper? Paper B. How many percent is paper? Let's use that one too, so that everybody can understand how it works. How many degrees of the pie chart represent paper? According to the question, paper is
162.
No.
162.
Let's leave degree for now. You have seen how to handle degree, Abi?
Yes,
You
sir.
saw how I solved the degree on. Let me now solve without using degree. Paper is 45%. So I can now just go straight 45% of 12,000 units. I will get the answer. So that means Roman figure 4, paper
Excuse me, sir.
Yes.
Does that question, are we carrying the figure we are given in Roman 3? Are we extending it to IV? I thought that's line 3. Roman figure 3 is just specifically for just that. Then number 4 of that question is in line with the main pie chart.
Okay, don't worry. We'll do the two so that. No, don't worry. It's not. There's nothing to look at. Just look at the part.
Okay.
I'll do it in 2 ways so that you can understand. The question say how many what? How many units, Abi? Is it
No,
units?
sir. It
So
says
the
how many
question
degrees
says,
of the pie
how
chart
many
represents
degrees
paper?
of the pie chart? Referring to the pie chart. How many degrees of the pie chart represent
how many
paper?
degrees? We
How
have
many
done it.
degrees?
Now there's no need now. Don't need to
Yes.
bother
Just
ourselves.
162.
It has been done.
162.
So what? 160 what?
2.
2, Abi. We have done it. So there's nothing again. Thank you. There's no need stressing myself again. So it's already done. I thought it has not been done, but we have done it. So that is the answer to question 2. We have done 1, we have done 2. The step now is to move to 3. Any question for 1 and 2? For number 3, if you still have that, number 3 says the data below shows the performance of a newly advertised product in terms of daily sales volume, which is in 1,000 units by an advertising company. This is what we call group data. And there are 2 types of grouping in statistics. We have up to grouping and less than grouping. This one you are seeing on the board from 5 to 10, 10 to 15, 15 to 20. Like I said, we have 2 types of grouping. One is called up to grouping. 2 is called less than grouping. When you have up to grouping, every group is independent of each other. Did you get that? When you have up to grouping, that is a type of grouping where every group is independent of each other. Second one is the opposite, less than grouping. Every group is not independent. Look at this question. This question is a typical example of less than grouping. First group starts from 5, but is less than 10. Am I correct? Because the next group is starting from 10, less than 15. The next one is starting from 15, but less than 20. The next one is starting from 20, but less than 25. That's the meaning. The next one is 25 less than 30 because the other group is starting from 30. So this is a group that is not independent. And when you have a group that is not independent, then that is what we call class boundaries. This is class boundaries. This one, you don't need to subtract 0.5 and add 0.5. This is already in class boundaries. I don't know whether you are getting me. This is what I'm saying. Maybe I put it on the board and let you know. For instance, this particular question, I have 5 to 10 for the first group. I have 10 to 15 for the other one. I have 15 to 20. Let me just stop here. When I take 10 to 15, this is what we call class. boundaries. This is what we also call less than groupings. These are called less than groupings. When you have a less than grouping, this 10 you are seeing is called lower class boundary. Lower class boundary. This one you are seeing is upper class boundary. If you check what is on the board, which has been your usual practice, I did not subtract 0.5 from 10 and add 0.5 to 15. No, because this group is not independent of each other. There is a link between group A and B. When there is a link between group A and B, it is less than grouping. And that is known as class boundaries. The first number is the lower class boundary, and the second number is the upper class boundary. Remember that if you are finding mean, mode, median of a group data like this, our formula for calculating them is always based on class boundaries. That is why when you are giving the other grouping, which is up to grouping, which we call class limits, you must change it from class limit to class boundary. But copy this one, we'll throw more light on the second type of group. Just for objective sake, so that they can ask you boundaries or limits.
So the first one, you said less than what? Is it less than G or what?
No, less than grouping. That G is grouping.
Okay, grouping.
Yes.
All right.
I said there are two types of grouping. This is one of it, which is out through the board.
Please hold on, sir. I'm still writing, sir.
No, no problem. No problem. I'm not in a hurry. Remember, we're in question 3, trying to analyze before we get the answer. Are we true?
Yes, sir, we are true, sir.
Good. So the second type of grouping, that one is called up to grouping. Up to grouping. That one is always independent. For instance, you can see maybe 5 to, let's say, 8. There's a group. Another one will start from 9. They have 12. Another one will start from 13. So maybe 16. You can see this group. This group, each of them is independent. First group is 5 to 9, 5 to 8. It does not extend to the next group, which is 9 to 12, 13 to 16, like that. So that is just how that group works. Okay. Now I'm having here 9 to 12. There is a group. This group is an example of up to grouping. And when you have up to grouping, you call it class limits. Class limits. And when there is class limits, this 9 is called lower class limits. This 12 is called the upper class limits. When you have class limits, you cannot use class limits to calculate mode, median, because the formula for mode and median is around the class boundaries. All you need to do is to change the class limits to class boundary by subtracting 0.5. For instance, 9 to 12 are whole numbers. When it comes to whole numbers, you subtract 0.5. When it comes to 1 decimal place, you subtract 0.05 from the lower class limit and add 0.05 to the upper class limit to change it to boundaries. For instance, this is 9 because it's a whole number. I'll subtract 0.5 from it. It will now give me 8.5. So that 12, I'm going to add 0.5 to it. It becomes 12.5. That means I have just changed 9 to 12. 9 to 12 is a class limit. I have just changed it to class boundaries. I hope somebody is following. I have changed 9 to 12, which is class limits, to class boundary, because class limit is not useful for the calculation of mode formula for group data. It's not good for median calculation of group data. You must change it to boundaries. So this 8.5 will now be lower class boundary. Why this other one will be upper class boundaries. That is a simple analysis of different types of groupings. There are only two. One is up to grouping, that type of grouping that is independent. That type of grouping that gives us class limits. That type of grouping that we must change from class limits to class boundary. That type of grouping that in the process of changing it from class limit to class boundary, if the group is in whole number, I will subtract 0.5 from 9 to give me 8.5, which is the lower class boundary. I will now add 0.5 to 12 to give me 12.5 to become class boundaries. But like I said, because it's objective you are doing, if the boundary, if the group you were given is not whole number, maybe this 9 you are seeing here was originally 9 point maybe 2 to 12 point maybe 2. This 9.2, I'm going to subtract 0.05, and I'm going to add to 12.2 0.05. So if it's a whole number, you subtract 0.5. If it's a one decimal place, you subtract 0.05. If it's two decimal places, you subtract 0.005, and so on. Any questions? So to solve our question, which is not difficult again, the question says, number of days is the frequency. You say A, calculate the mean.
Sir, sorry, sir.
Yes.
Please, let me take you back now, sir. Sir, there's something you just said now. You said you started by saying that if it's odd number, we subtract 0.5 from 9 and add.
Wait. I said if it is whole number, not odd.
Okay, whole number. Sorry.
Whole
number.
Whole
okay.
Number. Yes, there's nothing like odd inside.
All right. Then you said, okay, we add to 12 to give us 12.5.
Yes.
Then there was another statement you said. When is it 2 decimal?
No,
or
1 decimal. No, if it's 1 decimal.
Okay.
If that group was 1 decimal, I know that is not common, but anything can occur. If it's 1 decimal, like 9.1.
Yes.
So maybe 12.1. You know that 9.1 is 1 decimal, B?
Yes.
For you to convert it from class limit to class band, you subtract 0.05 from 9.1.
Okay, 0.05.
Yes, it will just increase. 0 will just be there.
Okay.
That one we did was 0.5 because it's a whole number.
Okay. Thank you, sir.
You're welcome. So the question says A, Calculate the mean daily sales, just calculation of mean of the project using the midpoint of the class 20.25 as the assumed mean. This question is trying to tell us to do what they call assume mean. And for us to assume, I have to write all those things down and then do them one by one. But let's start. The first part, you help me call these numbers while I'm on the board. For that board, this is what we're having. Let's do it this way first. Okay. We'll do like this. 1, 2. You have this one is another one. We're having something like this. This is a group. I hope that group is sales volume, Abi.
Yes, sir.
Then this is the frequency. Abi, number of days is known as the frequency. This is the sales volume. I have to leave the sales volume like that because that's not what I need. The first one there was 5 to what? 10, Abi.
5 to 10.
Then 10 to 15. Abi? 15 to 20. 20 to 25. So I have started solution. Oh, we are solving number 3 now. 25 to 30. Then 30 to 35. 35 to 40. Did they stop at 40?
Continue.
Where did it stop?
At 45 to 50.
Okay. 40 to 45. Then 45 to
That's
50.
the last one.
Stop at 50. Good. Now, our frequency, can you remember the value? 5 to 10. Call the numbers from the first one. 5 to 10. What is it?
4.
Number 1 is 4.
8.
8. 18. 64.
64.
40.
40.
28.
28.
14. 7. And 3. 3.
Good. What we are looking for is question A. We say we should find the mean, daily mean, or mean sales, or whichever daily. So, and it say we should use assume mean approach. We are going this way. We have to find what they call, they mention it there. They mention midpoint, Abby. I saw something like that. Did you see something like that? So this is our X. That midpoint, as the scale X could be under the midpoint or up, whichever one. And when they say midpoint, remember 5 to 10. 5 to 10. 5 is the lower class boundary. 10 is the upper class boundary. We are going to do a simple mean. 5 plus 10 is 15, Abi.
Yeah.
15 divided by 2, 7.5. The next one, 25. What do you have? 12.5, Abi. Are they with me? 10 plus 15 is 25. 25 divided by 2 is 12.5, Abi.
Yes, sir.
Between 7.5 and 12.5, what's the difference? 5, Abi.
Yes, sir.
So I don't need to worry myself. I will just be adding 5. Just be adding 5 just be adding 5, but help us cross check if you know what we're doing. 32.5, 37.5, 42.5, 47.5. I hope I got all. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. I hope you understand.
Yes, sir.
Good.
Yes, sir.
And the question says we should use an assumed mean, Abi.
Yes,
An
sir.
assumed mean of from the group 20 to 25. So this 20, what are they call it? 22.5 is our assumed mean. Is it clear?
Yes, sir.
So that's why I put A there.
That's class
Where,
boundary.
which one?
That's for the class boundary for 20
No,
to 20.
Midpoint. The midpoint.
okay, the midpoint, which is 22.5.
Yeah,
The class boundary of 20 to 25, Abi.
yeah.
That's the one they say we should choose as our assumed mean. And that's why I have adopted 22.5 as our assumed mean. Is it clear? Any question? There are two types of mean. We have actual mean and assumed mean. So when they talk about assumed mean, so we are going to use assumed mean to find the actual mean. If they say we should find the actual mean, we would have just done that. Would have just written on top f times x, f times x, f times x. Frequency times x, we multiply and add it together all over the total number. That would have given us mean straight away. But this question didn't want it to be easy. They want us to do a lot of calculation. What I wrote now, this is alphabet D. The next column is alphabet what? D. That is small d I have written there. And that D means deviation. That D means deviation. Are you there? And deviation here simply means x minus a. Deviation. In that bracket, check it very well. That D I wrote on top. Under it, you are seeing x minus capital A. A is assumed mean. X is the variable. That variable is the midpoint column. Are they with me?
Yes, sir.
Yes, sir.
Good.
Go on, sir.
So now that I've gotten deviation, the next column I'm going to get is F times D. When I get that division, I'm going to use the frequency to multiply the D. So I start. The first X you are seeing on the board is 7.5, agreed?
Yes, sir.
And our A is 22.5. Help me subtract.
That will give us
7.5. It will give us minus 15.
minus 15.
Good. The next one,
Minus
12.5
10.
minus 10. Good. The next one, 17.5 minus 22.5. What do you have? Minus 5, Abby. Is that correct?
Yeah.
This is 0. 27. This one is ordinary 5. This one is 32.5 minus 22.5. That is 10. The next one 37.5 minus 22.5, that should be 15. 42.5 minus our assumed mean, that should be 20. 47.5 minus 22.5, that should be 25. Any questions? If you look at the table very well, the next table is F times D. Remember, we are not finding variance. We are finding mean using an assumed mean approach. So we are going to multiply 4, which is the frequency, times minus 15. It will give us minus 60, Abby.
Yes, sir.
8 times minus 10 is minus 80.
80.
Then 18 times 5, somebody help us. That should be 90, minus 90, if I'm not missing
Yes,
it.
sir. Minus 90.
And this is already 0. 40 times 5, that is 200. 28. I hope that frequency is 28. Am I correct?
Yes,
That
sir.
is 280. Then 14 times 15, somebody help us. 14 times 15.
210.
Huh? 210. Okay. This one is 140. And the last one there, 25, 75. The space down is not helping us. So we're going to add this column. We're going to add frequency, the column. So what you are going to do for me here, I'll just write it somewhere. The total for F and the total for FD. Total for F and the total for FD. So 4 plus 8 plus 14. It seems they are 300, Abby. Did they say something like that? Abby? Okay, they didn't say anything like that. The data shows the performance of newly advertised products. Okay, they didn't call number. So let's add. You're going to add for me 4 plus 8 plus 18 plus 64 plus 40 plus 28 plus 14 plus 7 plus 3. What do you have as a total?
186.
186.
I'm circling it to know that is the total there, which should be under. We should have drawn the line under. So, but that is the total. Please draw it under and put it total 186 under that column. This one is there's a lot of minus there. So minus 6. Okay, everything 275, Abby.
675.
Okay, 675. This is the total under that column. You draw a line and put it 675. That is for that one. So please copy it because we're going to go to the next agenda and write the mean. This is a Roman figure or question A. Let me see whether it's it that is written there.
Sorry, sir. Is this for FD or this?
Number 3A. We're in number 3A.
No, I know this is self-regular, sir. Is it for FD or D?
You said?
This total of 675, is it for FD or D?
Yes, FD, yes. Total for FD is 675, which means minus 60 minus plus minus 80 plus minus 90. Minus 60 plus minus 80 plus minus 90 plus 200 plus 280 plus 210 plus 140 plus 75. The total is 675. Is it clear? Outro?
Yes, sir.
Good. Still on question A. This is 3A, which is the assume mean approach. So according to the question, the mean daily sales, I believe, is equal to that assumed mean plus summation of FD all over summation of F. From all indication, our assuming is 22.5 plus, I thought you say you got 675, I believe. Abi? All over 186. This is what you got.
Yes, sir.
It will be 22.5
Plus 364. 364.64.
Wait.
That'll be 3 point.
3 point what?
3.64.
3.64.
86.
Okay, 86. Let's just leave it like that as 5 here, Abi.
Yeah.
So add the two together. This is a point to of this. As a point, 3.65. So what's the total? 20. 20 what? 26, Abi. 0.1, Abi. 5, Abi. Is that correct? Okay. So that's how to find mean. Let me use the language they use there. Let me use the language there. The question says calculate the mean daily sales. So our question there, mean daily sales volume of the product is 26.15. That is the answer to that question.
Listen.
Huh?
Yes, sir.
Yeah.
I don't know how they have a 3.65. The real answer is 3.63.
Okay,
No.
but the value is still 675, Abi.
Yes.
It's still 675. It's 3.63 precisely.
No.
Okay, 6 point. Wait.
It's going to be 3.6483 now.
Okay, don't worry. Let me solve the
It's
redo.
26.13 that should be the final answer.
But what matters here is that it was 675 on top, Abi.
Yes.
Divided by 186. So I got here 3.63, Abi.
Yes, sir.
Okay.
3.63 should be the right thing there, not 4. Then plus 22.5. The answer is 26.13.
Yes.
Good.
Yeah.
So that means from all indication, this is 6.3. And if it's 6.3, it's going to be 1.3. Good. So that the answer is 26.13. Based on that, I haven't found, that means question 3A has been answered. Question, what is it called? 3B, say compute, which I don't think we can do today. That 2B says compute the coefficient of variance of the daily sales volume. If you have forgotten, let's remind you. Coefficient of variance is equal to coefficient of variance, that is 3B. Coefficient of variance, according to the question, is equal to standard deviation standard deviation all over mean. We have only gotten mean in this question. Am I correct?
Yes, sir.
But we have not gotten standard deviation. And we need to calculate again to get the standard what deviation. If I can just use that idea, let me see whether the information is not complete, because that thing we did before, we did deviation alone. So that means we need an additional column to get deviation square. Deviation what? Square. That means I'll have to do that before I find my way for today. You have to look for standard what? Deviation, which is given as...
Excuse me, sir.
Yes, I'm hearing you.
Yes, sir. At this point, are we still to maintain using an assumed mean of 22.5 now that we now know the real mean?
No, already, yes, we use that assumed mean to get the real mean. Is that okay?
Yes, that's what I'm saying.
So
Either we have the real mean.
Yes.
We can go back to now find the new deviation.
No, that would be a waste of time, because there is a formula used in finding standard deviation under that same formula. So you don't need to waste your time, because all you just need to do there, you can see the formula I'm writing on the board, so that with this formula, you know what I'm talking about. FD all over summation of F, all raised to the power of 2. I know that the deviation has square root, Abi. So you can see that in our original formula, we know this one, Abi. Hello? In our original formula, what is in this bracket? We know it. And we know this one in the bracket. We just used it some few minutes ago now. That was the one you did. 675 divided by 186. Whatsoever we'll get here, we'll square it. We'll put it down. But like this one, we don't know this first one, because we just calculated D. That our D that we calculated, which is deviation, that we got minus 5, minus 10, minus
15, that. 10, yeah.
We just need to find D square. Immediately we find D square, we'll be able to find FD square and be able to replace this column and find standard deviation. When we get the standard deviation, that's what we'll put as numerator plus our mean to give us coefficient of what? Variance. And that is the answer to that question 3B. If you have questions, you can ask, because we can't run that before it's almost 10 o'clock. And the last one says, comment fully on the performance of the product with respect to your stability in the market. Well, that one is not difficult. Immediately you get that standard deviation, the coefficient of variance. That coefficient of variance you get, it will show us how risky the business is, how the market is. So if the percentage is high, we say that the market is risky, that is not stable, and it's better we don't invest. Just like what we did one time when you were doing finance, that we were looking for probability based. So when you find the coefficient of the variance, if the percentage is high, we say that the business or the market is not stable and is risky to invest in this kind of business. So that is all we can take for question 3 out of the 10. We can only do 3 today. Maybe on Thursday, by His grace, we may continue with other things, depending on whether it's to solve question or to continue on this, whichever one. But at least we have shown you a little. Any questions based on what we have done today? Number one.
I learned that we might be submitting this assignment on Friday.
On Friday?
Yes, sir.
We'll see what we'll do. That means just like they have made me to understand, I'm going to use my hand to solve the rest and send it to the appropriate quarters. Is that okay?
That's fine,
no
sir.
problem. No
Thank you,
wahala,
sir.
because what we did here was just to give you an idea in case it comes out in objective, to be able to put one or two things together. So no problem.
Thank you so much, sir. I really enjoy your class.
Thank you very much.
I wish we have time to continue.
It's just that it's almost after 10. So
yes, thank you so much, sir.
Everybody wants to go somewhere tomorrow, which is work.
Yes,
thank you, Vincent. We appreciate you.
Thank you very much.
We really appreciate it, sir. I enjoyed it, because if you are just giving us only solution without understanding, I won't understand it. But at least with this understanding, I have an idea of it, sir. We're so grateful, sir.
You're welcome. I hope you have subscribed to my YouTube channel, Author Vincent Nwankpa. Try and subscribe. That one has statistical stories. You can still pick one or two things. Author.
Can you write it, please?
Yes.
Author Vincent, Vincent, Vincent.
I was still writing the formula. Hey, okay.
Vincent. No, I have not cleaned it. You will see it back. Don't worry.
Okay.
I know they clean anything. Don't worry. You see it back. Author Vincent Nwankpa. This is the spelling.
This one, a real author.
Author Vincent Nwankpa. So this is the YouTube channel for this statistical thing. Premium publisher was for finance. So this one is for statistics.
Yeah, I'm following right away.
Have you written it?
Yes,
okay.
Sir.
So the person that says he has not copied. Okay, I don't know whether it's this one. They have not copied.
It's not this one.
Okay.
The coefficient of variance.
Okay, this one. Oh, no, not this one.
Not this one. Coefficient of variance.
Are you sure it's there? No.
It's gone.
I don't come out. No, it's there. It's
before
there.
this one.
It's there. So is it, Abi?
Yes.
Good. You can copy, sir.
Hello, sir.
Yes.
Yes, sir. Please, can you use that table to explain the...
Okay, that one, Abi?
Yes, how you get the...
Okay, let me see where it is. That table. No. Let me see. I believe it's here. This is the table, Abi?
Yes, sir. This is it.
You put D square, D raised to power 2. You now put another column, F D square. Is that okay?
Yes, sir.
This is our D. Our D is minus 15 that you are seeing, Abi. When you square the D, you get 225. You get 100. You get 25. You get 0. You get 25. You get 100. 100. You get 225 here. And you get 20, which is 400. You get 625, which is 25. You will now use this F to multiply this D square to give you this column. And it is this last column that you need. Summation of this last column all over 186 will give us that first formula you saw. Is that okay?
Okay, sir. Understood, sir.
I hope that is clear.
Yes, sir. Thank you very much, sir.
On that note, God bless you all. See you on Thursday again to conclude the revision, whichever one. On that note, if there's no other question, God bless you. That's all we can take for today.
Okay, thank you very much, Mr. Vincent.
Yeah.
So on Thursday, we'll continue the good work. Thank you, everybody online. I believe this really help for the assignment and the forthcoming exam.
Seriously.
All right, thank you. Good night.
Good night, Mr. Gideon. Good night.